Hello all. In today's lecture, we are going to study about Quine method. It is also called as a tabulation method. This technique is mainly used for simplifying your Boolean expression. You can ask me, like, we already have a K-map for simplifying a Boolean expression. Then what is the need for going to this Quine method? The reason being, in K-map, the maximum variable that we have used for solving a Boolean function is 4 or 5. Right? Either 4 or 5 at the max. What in case if the Boolean function had more than 6 or 7 variables like C, D, E, F, G, H, etc. If we have more than 6 or 7 variable, still we can solve it using K-map, but it is a bit tedious, and that is the reason we are going for Quine-McCluskey method or the tabulation method for solving the Boolean function with many variables. Fine, let's solve some few problems. After that, you'll be able to understand how to solve any Boolean function using a tabulation method for getting a simplified or a reduced Boolean expression. Clear? Fine. If your question is like simplify the Boolean function using tabulation method, and if they've given you some minterms, then how are you going to solve it using tabulation method? For that, your first step is you have to take out all the minterms and then you have to represent them using a binary form. Let's take the minterms. These are 0, 2, 3. I'm taking out all the numbers here. There's 6, 7, 8, 10, 12 and 13. Right? Your first step has to be to represent all these decimal numbers in its equivalent binary form. Fine? How do you represent 0? It is 0, 0, 0, 0. And for 2, you can represent it as 0, 0, 1, 0. For 3, it is represented as 0, 0, 1, 1. 6, it is represented as 0, 0, 1, 1, 0. 7, you represent it as 0, 1, 1, 1. 8, it is represented as 1, 0, 0, 0. 10, it is 1, 0, 1, 0. 12, it is 1, 1, 0, 0. And 13, it is 1, 1, 0, 1. This is how we'll be representing the decimal number into its corresponding binary number. Fine. Clear? This is how you'll be doing a table or the tabulation. Now you have to fill in this table. How do you do that? Based on the minterms, your first step has to be to categorize these minterms based on the number of occurrences of the number 1. How many times the number 1 is occurring? Based on the occurrences, number of times the number 1 is occurring, based on that you will be classifying these minterms into different groups. First, let's take the number 0. Do we have 1 here? No. So, let me take 0. And whatever is the corresponding binary number, I'll be representing it here. Here, in this number 0, I don't have any 1. So, I'll be taking it as a single group. When you see in all the remaining minterms, you have the presence of 1 at least 1 times. So these all will be coming into a different category, different group, which we will be dividing it further. I'll explain you that. For now, let's take the number 0. Since it didn't have any occurrences of 1, we are going to consider this as a separate group. Clear? Your next step has to be to identify and group the numbers which are having the number of occurrences of 1 as 1 time. So clear? Here, when you check on the next number, the number 1 is occurring only once. So I'm going to take this. Right? Now, check on the next number. The number 1 is occurring 2 times here. So we will leave it. We are going to consider the number of occurrences of 1 as only 1 time. We are going to take out only those numbers. Clear? Here. For the number 3, the number of times the number 1 is occurring is 2 times. So we are going to leave it. Here for the number 6, here again the number of times the 1 is occurring, it is 2 times. So leave it. For the number 7, we have 3 times the number 1 occurring. So we will leave it. Take the number 8. Here you have only 1 time. So we will include it. We are considering only single occurrences of 1. Fine. And let's take the number 10. Here you have 2 times the number 1. So we are going to ignore it. And then next number 12. Here again you have 2 times the number 1. So we will leave it. Take the number 13. Here you have 3 times the number 1. So we will leave it. Now group the numbers which has got single occurrences of 1. Fine. Here number 2 and number 8 alone had only 1 time the occurrence of 1. Fine. So these two numbers, I'll take it as a separate group. I'm going to mention the numbers. What are the numbers? It is 2 and 8. Understood? These two will be taken into a separate group. And give me the binary number. It is 0, 0, 1, 0 for 2, and for 8 it is 1, 0, 0, 0. Understood? Based on the number of time the number 1 is occurring, accordingly you will be categorizing or you will be grouping the min terms. Fine. Here the number of occurrences of 1 is 0. In this group the number of occurrences of 1 is 1 time. Your next group has to be the number of times the occurrences of 1 has to be 2 times. Fine. Now let's check. Number 2 we have already written it here. Fine. Now we are going to check for the number of occurrences of 1 is 2 times. Fine. Here when you take the number 3, there is 2 times the number 1 occurring. So we are going to include this. Take the number 6. Here again the number of occurrences of 1 is 2 times. So I'll include this. 7. Here the number of occurrences of 1 is 3 times. So we are not going to include this. 8 we have already written. Take the number 10. The number of occurrences of 1, it is 2 times. Wherever you find the number of occurrences of 1 is 2 times, we are going to put a tick mark and we are going to take that as a single group. Clear? Now, check for number 12. Here again, the number of times the number 1 is occurring is 2 times. So this again, I'll put a tick mark. Is it clear? Now, check on the number 13. Here the number of times the number 1 is occurring, it is 3 times. Right? So, I'll ignore it. I'm considering only the number of occurrences of 1 is 2 times now. Now, which all number had the number of occurrences of 1 is 2 times? Number 3, number 6, number 10 and number 12. These 4 numbers had the number of occurrences of 1 as 2 times. Right? 2 times the number 1 is occurring in all these numbers. Got it? Now all these numbers I have taken and I have put them as a single group. Now write the corresponding binary number. For 3 it is 0, 0, 1, 1. And for 6 it is 0, 1, 1, 0. For 10 it is 1, 0, 1, 0. And for 12 it is 1, 1, 0, 0. Is it clear? While writing, see to it you write it in a proper alignment. I put the binary representation as A, B, C and D. So write the digits again in A, in line with B, in line with C and then in line with D. Clear? Now, this group, the number of occurrences of 1 was 0. Here in this group, the number of occurrences of 1 was 1 time. This group, the number of occurrences of 1 was 2 times. Now the third group will carry the number of occurrences of 1 is how many times? 3 times. Right. Now check on the number. Whichever number had the number of occurrences of 1 as 3 times, those numbers alone we will take it and then we'll put them in the last group. Clear? Here. We are done with 3, 6, we are done. Now go to the number 7. Here the number of occurrences of 1, it is 3 times here. Right? So I will include this. 8 has got only 1, 10 has got 2 times, 12 has got 2 times. We are going to concentrate only on the number which has got 3 times the occurrences of 1. Fine. And when you check on the number 13, this again had 3 times the number 1. So I will include this. These two numbers I'll take and I'll put them as a group in the last column. Here it is number 7 and number 13. Give me the equivalent binary representation. It is 0, 1, 1, 1. And for 13 it is 1, 1, 0, 1. Are you clear with how to do the grouping here? Fine. Now let's move on with the next column. How to write the paired implicant. For that, you have to take every group, every element in one group, and you have to compare that element with every other element in the successive group. Fine. How do you do the comparison? You have to compare them bit by bit. What do you mean by bit by bit? Bit meaning every single digit in a binary number is called a bit. Fine. While doing the comparison, you have to compare all the elements of one group with all the elements of the other group. While comparing, you have to check if there is one bit change. Then you will include both these numbers as a and consider them as a pair. If you find more than one bit change, then those two numbers you cannot take it as a valid pair. Is that clear? Let's solve it so that you'll understand it better. Now, the first group, I'm going to compare it with the first element of my next group. That is, I'm going to compare 0 with 2. While comparing, I'll be comparing digit by digit. So the first digit I'll be comparing. Here it is 0, here it is 0. Right? So both the numbers are same. So I go with the next digit. Here again it is 0, here again it is 0. So these two numbers are again same. Now I will compare the third numbers. Here it is 0 and here it is 1. What does it mean? There is one bit change. What do I mean by bit change? Bit change meaning when a number is changing from 0 to 1 or when it is changing from 1 to 0. Fine. This is called a bit change. At a time, only one bit change can happen. Here, while comparing, the first bit was same, second bit was same, only the third bit is changing. Right? So, one bit change has happened here. Now, check on the last number. Last number is again same. Both are zeros. So, between these two numbers, there is only one bit change that has happened. If there is only one bit change, then these two numbers can be taken as a valid pair. Is that clear? Now I'll be taking the number 0 and 2 and I'll mention it as a pair. Why? Because I found only one bit change happening. Understood? Now compare the first element with the second element in the second group. You have to compare every element of one group with every other element of the next successive group. Clear? Now let's compare 0 and 8. Compare them bit by bit. So check on the first number. Here it is 0, here it is 1. Meaning there is one bit change that has happened. Right? Now check on the second number. Here again 0, here again 0. So second bit there is no change. Third bit again, here also 0, here also 0. So there is no change. Check on the fourth number. Here again it is 0, here again it is 0. What does it mean? The digit position from 2 to 4 is same. Only the first digit is changing. Meaning there is only one bit change that has happened. So these two numbers I can take it and I consider that as a valid pair. So I can mention that here. 0, 8. Understood? Now, this is on comparing the first group with the second group. Since first group has got only one element, I have compared that particular element with the two elements of the second group. Got it? Now, the third group, you have to compare second group and third group. How will you do that? You have to compare 2 with 3. That is the first element of second group with the first element of third group. Clear? Now, check on the digits. Here the first element it is same. Second element again there is no bit change. Third element again there is no bit change. Only the last element has got a bit change. That is here it is 0 and here it is 1. The remaining first three elements are the same. Right? So, these two elements again I can consider them as a valid pair. Why so? Because there is only one bit change that is happening and it is happening on the last position. Is that clear? So I'll write 2, 3. Since I compared 2 with 3 and since I found only one bit change, so I'm going to include these two elements as a valid pair. Understood? Now, check 2 with the other element, number 6. You have to compare every element of one group with every other element of the next group. First, you will be comparing 2 with 3, 6, 10, 12. After doing this, again you have to compare the other element which is 8 with 3, 8 with 6, 8 with 10 and 8 with 12. Clear? Now, let's check for 2 and 6. Check on the bits. First bit it is same, Second bit, there is a bit change. Here it is 0, here it is 1. So there is one bit change that is happening. Check on the third number, it is same, both are 1, and on the last number again, both are 0. This implies that there is only one bit change that has happened between 2 and 6, and it is happening on the second position, right? So is this pair a valid pair? Yes. So I'll include 2, 6 again as a valid pair. Understood? Now, check 2 with the number 10. When you're checking 2 with 10, first bit, there is a bit change that is happening. Second bit, both are 0, so no change. Third bit again, both are 1, so no change. Fourth bit again, both are 0, so no change. So only the first bit is changing, meaning there is only one bit change that is happening. So this again is a valid pair. Which two numbers I checked? I checked 2 with 10. So I'll write that pair 2 and 10. Is that clear? Now check 2 with 12. Check on the digits. First digit, there is a bit change. Here it is 0, here it is 1. So one bit change has happened. Check on the second bit. Here it is 0, here it is 1. So another bit change is happening here. Already one bit change has happened in the first position. Now I am finding another bit change in the second position. At a time, there can be only one bit change that can happen. Only then you will group those two numbers as a valid pair and you can write. If you find more than one bit change, then those two elements cannot be taken as a valid pair. Understood? Here, when you compare 2 with 12, the first bit is changing. So it is one bit change that has already happened. Now second bit is also changing. So there is 2 bit change that is happening. So this is not a valid pair. So I cannot mention 2, 12 here. Understood? Now, compare 8 with 13. You are done comparing 2 with all the 4 numbers in the third group. Now take out this next number of second group, that is number 8, and then compare 8 with all the 4 numbers in the third group. Fine. Now let me compare 8 with 3. So when you compare the first element, there is a bit change. Here it is 1 and here it is 0. So there is a bit change that is happening here. Second element, there is no change. Third element again is changing. So there is a 2 bit change that is happening here. So these two elements I cannot take it as a valid pair. Is that clear? Now check 8 with the other element, that is 6. Let's compare 8 and 6. First element, there is a bit change. Here it is 1, here it is 0. So one bit change is happening. Second element again, there is a bit change. Here it is 0 and here it is 1. So second element is again changing. So there is 2 bit change that is happening. So I am not going to include this again as a pair. Clear? This is not a valid pair. Now compare 8 with 10. Fine. When you compare 8 with 10, let's compare the digits. First element, it is same. Second element, again it is same. Third element, there is a bit change. Here it is 0, here it is 1. So one bit change is happening. Fourth element, again it is same. So when I compare 8 with 10, there is only one bit change that is happening, and it is happening in the third bit position. The remaining all the elements are the same. So this pair, I can take it as a valid pair. Why? Because there is only one bit change that is happening. Is it clear? Now let me include 8, 10. Is that clear? Now compare 8 with 12. Compare the digits. First bit, no change. Second bit, there is a bit change that is happening. Here it is 0, here it is 1. So one bit change has happened in the second place. Third bit, there is no change. Fourth bit again, there is no change. So only one bit change is happening between 8 and 12. And that is happening on the second place. So this again is a valid pair or not? Yes, it's a valid pair. So I'll include 8, 12 also. Understood? Is that clear? How to compare the numbers and how to find out the paired implicants? In a similar way, you have to compare 3 with 17. That is, you have compared second group with the third group now. Now you have to compare third group with the fourth group. Every element of third group has to be compared with every other element of the fourth group. In a similar way. Clear? Now first step is to compare 3 with 7. So let's compare 3 and 7. Here first group, first element, no change. Second element, there is a bit change. Third element, no change. Fourth element, no change. So there is only one bit change that is happening, and it is happening in the second place. So this group, these two elements, I can take it and then I can pair it as a group. That is 3, 7. Clear? Now compare 3 with 13. First element, there is a bit change. Second element, again, there is a bit change. Right? So I cannot include this pair. Now, check 6 with 7 now. When you compare 6 and 7, check on the bits. First bit, no change. Second bit, no change. Third bit, no change. Only the fourth bit is changing. So this again is a valid pair. Fine. So what are the numbers that we check? 6 with 7. So I'll write 6, 7. Clear? Now compare 6 with 13. When I'm comparing 6 with 13, first digit, there is a bit change. Second bit, no change. Third bit again, there is a bit change. So 2-bit change has already happened. So I cannot include this pair. Now, check 10 with 7 now. When you compare 10 with 7, check on the numbers. First bit, there is a bit change. Here it is 1, here it is 0. So there is a bit change that has happened. Second bit again, here it is 0 and here it is 1. So there is 2-bit change that has already happened. That is not valid. So I cannot include these two. Compare 10 with 13. First bit, no change. Second bit, there is a bit change that has happened. Third bit again, there is a bit change. So I cannot include these two pairs. Now, compare 2 with 7. Sorry, 12 with 7. Check on the numbers. First bit, yes, there is a bit change. Second bit, no bit change. Third bit again, bit change is there. So these two numbers again I cannot include. Now compare 12 with 13. When I compare 12 with 13, first number it is same, second number same, third number same, only the last bit is changing. So these two elements again can be included as a valid pair. That is 12 with 13. Understood? How to write the paired implicants? Is it clear? Now, let's go with the binary representation. How do you write the binary representation? You have to take the pair. What are the elements in the first pair? It is 0 and 2. So check on the numbers 0 and 2. Fine. For 0, these are the numbers, and for 2, these are the numbers, right? Now, in this pair, which particular position had a bit change? On that particular position, you will mention a dash, and the remaining elements you will write as such. Fine. Now, let's do for 0 and 2 now. For this pair, this number corresponds to 0, this number corresponds to 2. Check on the bits. First bit, there is no change. For second bit, again it is 0 in both the case. Third bit, there is a bit change. So wherever you find a bit change, in that particular position, put a dash. Fine. The remaining elements, fourth bit, it is 0 in both the case. So I'll write a 0. Whatever number is matching, those numbers you have to mention as such in that corresponding position. Whichever number had got a bit change, only in that particular position you will be mentioning a dash. Is that clear? Fine. Now let's go with 0, 8 pair. So take the number 0 and take the number 8. Which position you found a bit change? Only on the first bit, right? So against this pair, on the first bit you will put a dash. Clear? What are the other numbers? Here second number same, third number same, fourth number same, right? So what are the numbers? It is 0, 0, 0. 0 in the second place, 0 in the third place, 0 in the fourth place. Whatever number is there that is matching, so irrespective of whether it is 0 or whether it is 1, if it is matching, then in that corresponding position, whichever number was matching, you have to mention that same number. And wherever you found a position, bit change, that particular position where you found the bit change, in that place alone you have to mention a dash. Is that clear? Now, let's fill on with the remaining numbers. 2 and 3. Let me take 2 and 3. For 2 and 3, first bit it is 0. Second bit it is 0 here in both the case. Third bit it is 1 in both the case. Fourth bit alone I had a bit change. So wherever I find a bit change, I'll mention a dash. Is that clear? Now 2 and 6. Take the number 2 and take the number 6. Where you found a bit change only on the second bit, right? The remaining bits are same. First bit it is 0 in both the case. Second bit there is a bit change, so put a dash. Third bit it is 1 in both the case. Fourth bit it is 0 in both the case. Is that clear? Now, check on the other pair. It is 2, 10. Compare 2 and 10. Here, first bit, here it is 0, here it is 1. So, there is a bit change in the first bit position. Second bit, it is 0 in both the case. Third bit, it is 1 in both the case. Fourth bit again, it is 0 in both the case. Is that clear? You have to write the binary representation of that particular pair against that pair. You cannot write it here and there. You have to write it adjacent to it. Clear? Now, check on the number 8, 10. 8 is here, 10 is here. Check on these two numbers. First bit, it is 1 in both the case. Second bit, it is 0 in both the case. Third bit, there is a bit change. Here it is 0, here it is 1. So wherever you find a bit change, mention a dash. Fourth bit, it is 0 in both the case. Is that clear? Now, coming to 8, 12. 8, 12 is here. First bit, it is 1 in both the case. Second bit, there is a bit change. Third bit, it is 0 in both the case. Fourth bit again, it is 0 in both the case. Clear? Coming to the last group, 3, 7. 3 is here, 7 is here. Check on the numbers. First bit, it is 0. Second bit, there is a bit change. Third bit, there is 1 in both the case. Fourth bit again, it is 1 in both the case. I hope you're following. 6, 7. Check on the numbers 6 and 7. When you check on the numbers, it is 0 in both the case, 1 in the second position in both the case, again 1 in third position in both the case, only the last bit is changing. Right? Now, for 12 and 13, 12 is here and 13 is here. Check on the numbers. First digit, it is 1 in both the case. Second digit, 1 in both the case. Third digit, it is 0 in both the case. And on the fourth bit, you found a bit change. Is that clear? How to write the binary representation of the paired implicants? Fine. Now let's move on with the quad implicants. Fine. How do you write the quad implicants? Quad implicants again, it is a similar way of how you compared the binary representation for writing the paired implicants. In a similar way, you have to compare these binary representation for getting the quad implicants. That is, here again it is the same. Every element of one group has to be compared with every other element of the next group. And if you find only one bit change in while doing the comparison, then those two pair you can take it for making it as a quad. What do you mean by quad? It is a combination of 4 numbers. That is called a quad. Right? Let's see how to do it. The normal procedure is you have to compare every element of one group with every other element. Say for example, you have to compare this group, this element of the first group with all the 4 elements, 5 elements of the next group. And then again, take out the second element, compare it with all the 5 elements of the next group. This is the normal procedure. And then you have to compare all elements of second group with all the elements of the third group. This is the normal procedure. But I'll give you some shortcuts so that it will be easy for you to solve during your exams. Clear? Now, how do you do that? Identify where you have a dash in which particular position. Fine. Here you have found a dash in the third position. Right? Now check on the other remaining numbers and see where you have got a dash in that exact same position. You have got a dash in the third position, right? So compare with all the numbers below and see where you have, which number has got a dash in the third position. Now this has got a dash in the first place, here last place, second place, first place. This has got a position in the third place. We are comparing with the third place. So this element has got a dash in the third place, right? Check on the remaining numbers as well. This has got second place, last. Only this particular element has got a dash in the third place. That is matching with your first element. Right? Now, compare these two numbers and see for one bit change. Dash again can be considered as a number here. Fine? Now, check for these two pairs. Check on the digits. First digit, it is 0 here, 1 here. So there is one bit change that has happened. Now check on the second digit. Here it is 0. Here again it is 0. So there is no change. Third digit, both are dash. So again no change. Check on the fourth digit. Both are again 0. So no change. Only the first digit has got a bit change. Meaning there is only one bit change that is happening between these two numbers. Right? So what is the corresponding pair? The implicant for this particular combination, it is 0, 2. And you compared this pair with 8, 10. Right? You compared these two elements. Right? So for this particular combination, what is its corresponding pair? It is 8, 10. So you will write 8, 10. Why did I write this? Because my first step was to identify in which particular position I had a dash. So I've got a dash here in the third place. So check with all the elements down below it and identify which number has got a dash in the same place. Here it has got a dash in the third place. Check for the elements which has got a dash in the third place. Only this element has got a dash in the third place, right? So compare these two numbers alone. If you find one bit change, then you can include these two pairs and make it as a quad. If you find more than one bit change, then you cannot make it as a quad. Is that clear? Now, let's take the second element. There is a dash in the first place, right? So check for all the elements which are below it and identify which element has got a dash in the first place. Let's check. For this number, there's a dash in the first place. So check on all the numbers. I've got a dash here in the first place. This element, is there any other element? No. Only this particular element has got a dash in the first place, right? So compare these two numbers. First element, both are having a dash, so no bit change. Second element, both are having a 0, so no bit change. Third element, here it is 0 and here it is 1, so 1 bit change has happened. Check on the fourth digit, both are zeros. So between this pair and between this particular pair, there is only 1 bit change that is happening. So I can include these two pair and form it as a quad. Clear? Now what are the numbers? It is 0, 8 for this particular pair, and for this particular element it is 2, 10. Clear? Now in a similar way, check for the other elements. Here I found a dash in the last place, right? So check the numbers below it and see which element has got a dash in the last place. Here I've got a dash in the last place in two numbers, right? So check these numbers. First bit, let me take 6, 7 first and compare it with 2, 3. Now on checking, the first element it is same. Second element, there is a bit change. Here it is 0, here it is 1. So 1 bit change has happened. Third element, it is same, both are 1. Fourth element, both are dash. There is no change. So only the second element is changing. That is, there is only 1 bit change that is happening. So I can include this pair and this pair and make them as a quad, right? So what is this pair? It is 2, 3, and the number we checked was 6, 7. So these two pair, I can take it and make them as a quad. Why did I make it as a quad? Because when comparing these two pair, I found only 1 bit change. Right? Now, we have another number also. So check on the last number as well. Let me take 2, 3 and compare it with 12, 13 as well, because this number also had a dash in the last place. Right? So let me check. First number, there is a bit change. Second number, again, there is a bit change. So 2 bit change is happening. So these two the pairs, I cannot take it as a quad. Why? Because there is 2 bit change that has already happened. Clear? Now, take on the next number. I have found a dash in the second place, right? Check for the number which has got a dash in the second place. I've got a dash here, I've got a dash here. Always you will be doing a comparison of one group with the elements of the next group. You will not be comparing the elements within a group. Here, this dash, which is in the second place, is within this group. So I will not be doing a comparison to this number. Understood? I'll be doing a comparison always with the elements of the other group. So I'll be doing a comparison here. Here on checking. The first element, it is 0 in both the case. Second element, it is dash in both the case, so no change. Third element, it is 1 in both the case, so no change. The fourth element, here it is 0 and here it is 1. So there is 1 bit change that has happened. So these two elements, I can take it and I can make them as a quad. What are the elements? What are the pair? It is 2, 6 and I compared it with 3, 7. Clear? Now, moving on. Identify which element has got a dash in the first place. There is no element which has got a dash in the first place below it. Now, identify which element has got a dash in the third place. No element is having. Here, when you want to compare 8, 12, I've got a dash in the second place. So check on which element has got a dash in the second place. This element. So check if you have 1 bit change here. First bit, there is a change. So there's 1 bit change happened. Second bit, it is same. Third bit, there is a change. So 2 bit changes already happened. So I cannot include this pair. Right? And the remaining elements are within a group we cannot compare. So we will ignore it. Fine. So altogether, you have got 4 quad. How do you write the binary representation? This combination you have to take. that is 0, 2, 0, 2 with 8, 10. Identify which particular position had got a bit change. On that particular position, you will be mentioning a dash, and the remaining elements, whichever is common in both the case, you will mention them as such. Now, on comparing 0, 2 with 8, 10, 0, 2 is this set and 8, 10 is this set. Now, comparing the first element, there is a bit change. Second element, it is same in both the case, which is 0. Third element, it is dash in both the case. And fourth element, it is 0 in both the case. Right? Now, check for 0, 8, 2, 10. 0, 8 is here, 2 and 10 is here. Check for the digits. Wherever you found a bit change, you have to mention that with the dash, and the remaining elements you have to write as such. Clear? Now, I am comparing 0, 8 with 2, 10. First element, it is dash in both the case. Second element, it is 0 in both the case. Third element, here it is 0, here it is 1. So, bit change is happening. And then fourth element, it is 0 in both the case. Understood? Now, when you see both are same, what do you mean by that? Whatever numbers you have in a quad, if it has been given in a swapped format, like 0 to 8, 10, it has been swapped and it has been given as 0, 8 to 10. Both the numbers are same. All the four numbers are already here in this as well, but they are given in changed order. But your final binary representation is the same. So can we write it once? Right. So we will write only once. If you find a quad getting repeated again with the same numbers but in a rearranged format, then you can write them only once. Fine. So I'm going to write only once. In a similar way, check for these numbers. It is 2, 3, 6 and 7. I'm having the same numbers but in a jumble format. 2, 6, 3, 7. All the four numbers, same numbers I'm having but in a rearranged format. So the output is going to be the same, right, in both the case. So can I mention that once? Yes. Now, give me the binary representation for 2, 3 and 6, 7. 2, 3 is here, 6, 7 it is here. Check on the digits. First digit it is 0. Second digit there is a bit change. Third digit it is 1, and fourth digit it is dash. Clear? Till this, I hope you are clear with the concept. Now, after this, you have to write the expression. Against, this is A, against B it is 0, against C it is dash, against D it is 0. Fine? We are using a sigma variable. Sigma meaning it is SOP. In SOP, 0 is represented with a complement and 1 is always represented with an actual variable. Now, since 0 it is here, you can write it as B bar D bar. Right? In a similar case for this, what is the equation? It is A bar C. Right? Now, this is not the final expression. You have got a quad and you have to do a back tracing now to identify if we have left out any term or not. How do you find the backtracking? Take out every pair and check it with your quad element. If you are getting that pair in that quad or not. If you are getting that element in the quad, put a tick mark. If not, you have to put a star. Let me explain. 0, 2. Let me take this pair and let me see if I can find this combination in this quad. So 0, 2, this pair, can I make it from this? Yes. Right? So 0, 2, I can make it as a pair. Now, check on the other numbers. 0, 8, can I make it as a pair here? Yes, these two numbers I can make it as a pair. So I'll put a tick mark here. Next, 2, 3. 2, 3, I can make it as a pair. So I'll put 2, 3. 2, 6, I can make it as a pair. So I'll put a tick mark here. 2, 10. 2, 10, I can make it as a pair here. So for that again I'll put a tick mark. 8, 10, this combination is again valid. So I'll put a tick mark here. 8, 12. Is 8, 12 coming anywhere here? No. So this pair has not been included. So put a star against it. Clear? Now check on the other numbers. 3, 7. 3, 7 can be made as a pair, right? So I'll put a tick mark. 6, 7. 6, 7 can again be made. This combination is also possible, so I'll put a tick mark. 12, 13. Is this combination coming in this square? No. So this combination is again not coming. So this element, this pair against it again, I'll put a star mark. Fine. Now these two elements, take it out and write it here. 8, 12. And what is the equivalent number for this? It is 1 dash 0 0. Fine. And in a similar way, for 12, 13, 12, 13, what is the equivalent binary representation? It is 1, 1, 0 dash. Right? So what is the expression for this? It is A, C bar, D bar. And for this, it is A, B, C bar. These four expressions we'll be taking and we will be considering them as a prime implicant for finding the final simplified Boolean expression. Let's see how to find out that. I'm writing this here. Fine. Now, these are my prime implicants. Whatever expression that I found here, those expressions I'll be mentioning it here. B bar, D bar, along with the numbers. It is 0, 2, 8, 10 for B bar, D bar, right? Similarly for A bar C, it is 2, 3, 6, 7. So I'll mention 2, 3, 6, 7. Clear? And A, C bar, D bar, A, C bar, D bar, it is 8, 12. In a similar way, for A, B, C bar, it is 12, 13. Clear? Now, I have to write the min terms here. What are my min terms? Whatever number is given for you in the question, those numbers you have to mention it here. So, it is 0, 2, 3, 6, 7, 8, 10, 12 and 13. Right? Clear? Now, how do you fill out this table? Whatever number is there, against that particular box, you have to put a tick mark. Fine. For B bar, D bar, what is the number? 0, 2, 8 and 10. This is for B bar, D bar, right? So these numbers, against these particular boxes, you have to put a tick mark. 0 against 0, against the next number it is 2 and the next number it is 8. So against 8 and the number 10. Is that clear? In a similar way, for A bar C, what is the number? 2, 3, 6, 7. That is what I have written here. For A bar C, it is 2, 3, 6, 7. I have written the same number. Against these particular numbers, in the boxes, you have to put a tick mark. Wherever you find 2, against 2, put a tick mark. And against 3, put a tick mark. Against 6, put a tick mark. Against 7, you put a tick mark. Is that clear? Now, for A, C bar, D bar, what is the number? It is 8, 12. So, against 8, put a tick mark, and against 12, you have to put another tick mark. Is that clear? Now, what is the next prime implicant? It is A, B, C bar, and the corresponding pair it is 12, 13. So, the same number I have written A, B, C bar, and the corresponding pair it is 12, 13. So, against 12 and against 13, I'll be mentioning a tick mark. Understood? Your next step is encircling. For that, you have to check the columns. Every column, whichever column has got only single tick mark, encircle that tick mark. Fine. If you find more than one tick in a single column, then you don't have to encircle any of the tick. Fine. If you find only one tick mark in a single column, then encircle it. Let's do it. Now, for the number 0, you have only one tick mark here. All the remaining 3 columns are empty. So, encircle it. Here, check on the number 2. There are 2 tick marks here. So, leave it. Check on the number 3. There is only one tick mark. So, encircle it. Check on the number 6. There is only one tick mark. Check on the number 7. Only one tick mark. Check on the number 8. You have 2 tick mark here. So, ignore. And check on number 10. There is only one tick mark. Check on number 12. There is 2 tick marks. So, leave it. Check on number 13. There is only one tick mark. So, encircle it. Understood how to encircle? Now, the final step for writing your simplified Boolean expression is check row wise. If you find circle in any particular row, include that expression. If you don't find a circle in any row, then ignore that expression. Now, let's do it. Here, in this particular row, we have got a circle. It can be single circle or it can be multiple circle. That doesn't matter. But if you find a circle in a row, then include that min term. Now, when you check on this, you have circles here. So include this term. Check on these. You have a circles here. Include these. Check on this row. You don't have any circle here. So you're not going to include this. Check on this row. Here again you have a circle. So include this. Right? Now the final expression is, let me write the expression here. F of A comma B C comma D is equal to B bar D bar. Whatever terms I have put a tick mark, I'll be taking only those terms. Right? B bar D bar plus A bar C plus A B C bar. This is my final expression, simplified Boolean expression for the given Boolean function using tabulation method. I hope you're clear with the concept. Let me sum it up. Whatever min terms are given to you, your first step has to be to take out the binary form. Fine. After taking the binary form, you have to group them based on the number of occurrences of 1. Here, the first group, it doesn't have any 1. Second group has got only 1 in their binary numbers. Third group has got 2 times the occurrence of 1 in their binary numbers. 2 times the occurrence of 1. In the third group, there is 3 times the occurrences of 1. Based on the number of times the number 1 is occurring, accordingly you will be grouping the min terms. Got it? Your next step is comparing every element of one group with every other element of the next group. You have to do the comparison digit by digit, that is bit by bit. While doing the comparison, if you find there is only one bit change that is happening between the two numbers on comparing, those two elements alone, those two numbers alone you will be taking, and then you will be grouping them as a pair. If you find more than one bit change, then you're not going to group those numbers as a pair. Clear? After doing the pairing, the next binary representation, this column is whichever position had a bit change in this particular pair. When you're comparing these two elements, whichever position had a bit change, that particular position you have to mention a dash. The remaining elements you'll write it as such. Clear? Next, coming to the quad implicant, it is the same. Wherever you have to compare every group with every other element in the other group, and the shortcut was you have to identify which particular position had a dash and identify elements that are below it and trace out which element has got a dash in the same position. Here we have got a dash in the third position. When you're comparing, only this element has got a dash in the third position. So compare these two elements and identify for one bit change. If there is one bit change, then those two groups you can combine together and then make it as a quad. If you find more than one bit change, then you're not going to make those groups as a quad. Is that clear? Now, after finding the quad, again, whichever element has got, whichever position had got the bit change in the quad, that particular position you'll mention as a dash. The remaining elements you'll write it as such. Clear? After this, you have to find out the prime implicants. Prime implicants is based on the final number, final binary representation, you'll have to find out the expression. After finding the expression, you should also check like if you have missed out any of the prime implicant. How do you check if you have missed out any prime implicant? The back tracing. How to do the back tracing? Take out all the pairs, check whether that particular combination you're able to make it in the quad. If you can make that combination in a quad, then that number you can put a tick mark. If you cannot make that combination in a quad, then against those numbers you'll put a star mark. Clear? And finally, the elements which has got a star mark, take out those pair again and the corresponding binary representation and take out the expression for it. Fine. Now, we have got 4 prime implicants. You'll mention it along with the corresponding pair or a quad. Fine. Now, all the min terms that is given to you in the question you have to write. Then against this particular combination, whichever quad or a pair is there in the expression, against those numbers you will put a tick mark. The next step is every column you have to check If there is a tick mark if there is a single tick mark in a particular column, then you encircle it. If there is more than one tick mark in a single column, then you won't encircle it. Clear? Now, after encircling, check row wise now. In every row, you have to check. If there is any encircling done in that particular row, irrespective of one time or n number of times, that doesn't matter. If there is an encircle done in a particular row, then that particular prime implicant you will be considering for your final expression. Now, in this particular row, you have got encircles, so you have taken it. Here again, on this particular row, we have got circles, so you are taking it. This particular row, there is no circle here, so I'm not including this prime implicant. And here again, I've got one circle, so I'm including this prime implicant. Fine. Whichever prime implicants are chosen, those prime implicants alone, I'll be taking it for my final simplified Boolean expression. This is how you'll be getting the final simplified Boolean expression for a given Boolean function using tabulation method. I hope you're clear with the concept. If you find my videos useful and informative, please do like, share and subscribe to my channel. Thank you.